Okay, you should be able to see my screen. Thank you for joining my talk. I'm Miro. I work at Narval, the company behind NX. I also co-organize in Vienna, Vienna.js and Angular Vienna meetups. So if you're around, stop by for a drink and a little bit of knowledge sharing. You might have heard about monorepos lately. If you were wondering what it is that the missing X that will make you a 10x developer? Or join forces with Copilot to steal your work and take over the world? You're in the right place, because this talk is all about the amazing and exciting world of monorepos. In order to understand how we got to the point where monorepos are a thing, we need to take a trip back to the very beginning of the web and retrace our steps, follow our developmental leaps. Fasten your seatbelts, it's history time. In the beginning, the web was static. It was merely a collection of HTML files linked by hyperlinks. And the first websites looked like this Yahoo page. They had lots of text, many links, a very contrasty choice of colors, and small images. The connection was via dial-up, so images had to be small. But there was something missing, the movement. So websites started adding animated GIFs. Remember this? Every website at some point had under construction GIF, or the overpopular dancing baby. Some websites took it to a whole new level, but the pages were still static. They needed something stronger. They needed a controlled movement. So Brendan Eich, employee of Netscape, the company behind the most popular browser at the time, created a new language based on Java that would add dynamicity to previously static content. And so the LiveScript was born, later renamed to JavaScript, much to the delight of generations of recruiters and headhunters ever since. The age of scripting began, and with it featured fancy image galleries, crazy menu effects, buttons that would run away from your cursor as you move your mouse. And the pages, well, they still looked horrible sometimes, but now they also had movement. As the number of scripts grew, the creativity flourished and the common patterns emerged. There was a lot of boilerplate and browser compatibility that needed to be abstracted away. The first UI helper libraries were born, and with them, the age of jQuery began. Now, jQuery wasn't the only one, but it's definitely a symbol of an era. The JavaScript code grew, and so did the possibilities. This was the first time when we started calling our websites web apps. Unfortunately, most of them were, well, spaghetti-powered apps, but manipulating the DOM wasn't enough. There was so much boilerplate to abstract away: routing, state management, event handling, code organization. All of this led to single-page applications. The first superstar framework was AngularJS, followed by React and Vue. But long before that, Backbone and Ember rocked the scene. And these frameworks are still used today. They helped shape the entire front-end industry as we know it. At the same time, our mobile phones became smart. People suddenly switched from surfing in front of their computers to trams, park benches, and of course, toilets. And we got back to dial-up days, as these first devices had weak CPUs and the network was 3G at best with lots of interruptions. In contrast to the early days of dial-up, people were less patient now because they seen that internet can be fast. So we needed to address the elephant trying to get squeezed through a straw. We needed something that was fast and light, in contrast to single-page applications that were heavy and took ages and megabytes to load. Also, web crawlers weren't very fond of the first SPAs. And so the whole JAMStack movement was born. Powerful meta frameworks like Next, Nuxt, or Gatsby hit the scene. Today, we also have Astro, Remix, and Quick that bring something completely new to the table. And the applications were again fast to load. But as your application grew, so did the build time. Our continuous integration and continuous delivery moved to the cloud, and suddenly your build queues not only resulted in frustrated developers, but also a steep monthly price tag. It was time for something more. It was time for monorepos. Monorepos are not new in IT. They have existed for quite some time, and they became a thing in JavaScript, especially for the open source projects with Lerna some 6 years ago. But to truly understand why monorepos are a natural evolutionary leap, we need to look at a typical application nowadays. So how does the typical application look like today? It usually consists of a homepage application built with some framework X, connected to a backend via REST or GraphQL or WebSockets. And then usually we have some custom or third-party UI components. But the backend is usually not a monolith nowadays. Most likely it consists of services linked via microservice architecture that is proxied behind your true backend. What happens often is that one of the methods in one of the services changes, but no one informs you, the maintainer of the front end. And suddenly, half of your UI is broken and you find out about it in production. So how do you test this? There are some clunky attempts to always export method contracts and models to TypeScript and inject them into your front end, but it involves human factor. And the human factor, given enough time, will always fail. And then there's a sync issue. Both changes on the backend and on the front end have to be rolled out together in sync, causing a lot of juggling and coordination. Also, your front end is probably not alone. There might be app for the mobile and app for the admin using the same technology, or maybe not, but using the same backend and same UI components. And those will be just as broken by the changes. On top of that, changes required by one of the apps now influence others. Not to mention that there are utility libraries that contain some shared functionality, and we want to make sure that when something changes in one of those projects, all the projects that are affected by the change are immediately checked. With a typical polyrepo approach, we need to publish a package, then run tests with the help of sophisticated code toggles, and if all goes well, we switch it on in production. This soon becomes a nightmare as it scales. And the precondition is first to know that the change actually happened and to have good security measures to prevent the changes from leaking through. Wouldn't it be nice if they could, well, talk to each other? And it's not just large enterprise applications that are affected. It's also every open source software out there. They usually consist of the main library, then some docs website to show the functionality and provide guides. And finally, you have some demos, some examples, and some showcases. And you definitely don't want to roll out new version every time you need to test something in a demo. You can, of course, use symlinks or local registry for this, but it's suboptimal at best. Again, if they could just communicate to each other, it would be way easier, right? With collocation, they can share the same repo. And as a consequence, they can refer to each other directly without the need of any special ceremonies like publishing or rolling out. And changes now become atomic. So if utility changes, your build, test, and lint in homepage and admin are immediately affected, and you can immediately see if your change broke something. Having things collocated helps us also to extract common code to shared libraries. Something as sophisticated as this amazing authentication that checks username and password can now live in a shared library that is used by all three applications above. Also, if one of the applications implements a cool feature that others would like to use as well, they don't have to now duplicate the code, or you don't have to publish it as a package. You can just extract it easily and use it in all three. And most people think this is all that monorepos are about. But there's more. Monorepos are not just about collocation. This is merely a precondition to everything else. It's the speed that is the main selling point. So let's unravel the magic behind monorepo tools. By having everything in one place, we can do a smart analysis of the solution and see how the projects are connected to each other and generate a dependency graph. This allows us to say that if our core library has changed, we know that based on the graph, the only two projects that might be affected by this change are store and admin. Now, what if the command that we actually want to run was deploy? Our core library is not deployable, but our admin and our store are. Our monorepo can then even further reduce the affected graph to just 2 nodes. Imagine the speed increase if you had hundreds of projects. Again, by knowing all the edges between project nodes, we can draw a nice up-to-date architecture graph. All monorepo solutions provide capabilities for such a graph, but only a few of them actually implement it. This is the graph of the NX project. The project itself is built using NX. You can see that there are quite some nodes, and that is a relatively small project. You want to split your project as much as possible so that every change is surgical and therefore fast. If we know how things depend on each other, we also know what can run in parallel and what cannot, and also what is the necessary order of invocation. This is called task orchestration. If we need to test build, build, and lint, a naive way would be to run them sequentially while making sure that they are in a correct order. A better way, though, would be to run build and lint in parallel, since they don't depend on each other. And once build is done, start testing the application. Even better way is to start testing parts as soon as they are built, so that we don't have to wait until entire build is finished. If you ever tried Lerna, this is the limit of its capabilities, which in most cases is enough, but it also leaves much to desire. First of all, it's a tool for managing JavaScript projects. So unless your project is written in JavaScript, like most backend probably isn't, your monorepo suddenly isn't so mono anymore. As the repository grows, even Lerna can't stop the speed degradation. Finally, Lerna doesn't provide any control over how projects are intertwined, leading to a potential mess as your solution grows. Eventually, your monorepo would go out of hand and your work becomes painful again. But luckily, there are other choices. Meet modern monorepo tools. Companies like Google and Facebook have had their monorepo solutions for a long time. To better align work, they keep large monorepos with thousands of projects. Such environment requires impressive build system to make sure everything is as performant as possible. Only recently, they decided to open up and share it with the rest of the world. But there was a catch. You might need a PhD to set it up, and most of it is not automated, so it requires a dedicated person working on it constantly. Luckily, some other companies decided to build tools that have the same features, but are built in a slightly more user-friendly way. And the most popular of them, NX, which also happens to be most feature-rich, we're going to be seeing now 3 examples. So let's see what are those missing features. Caching is probably the biggest differentiator between Lerna and all the other modern solutions. The core premise is to remember the state of the solution for which you ran certain command, so that when you run it again, you can replay the same results without the need to rerun it again. NX, for example, has the ability to cache the response of the executors, both file changes, for example, dist folder during the build, but also output logs, and it stores all of that locally. So next time you run the same command in the same environment, you would get a cached response instantly. And it would replay all the logs just as they happened the first time. And you can now mark every command to be cacheable, regardless whether it's a build, test, lint, translate, or resize images, for example. But it's not enough. Imagine you have a colleague, let's say in Australia, running the same commands on their machine and doing the same local caching. Wouldn't it be great if they could just use your caching results without the need to run it themselves? With distributed caching, your cache gets saved to the cloud. So the next time someone runs the command, NX will first check the local cache. If it's not found there, it will search the remote cache. And this is available to everyone, not just developers, but also CI pipeline, which then not only saves you time, but also money. No matter how smart your caching is or how affected graph calculation is amazingly built, every now and then you have to rerun everything. Whether it's a nightly run or an update of a main framework or a change of a node version. This is your typical worst case scenario where you can't really save work by doing some smart analysis ahead. And contrary to belief, it actually happens fairly often. But that doesn't mean your CI should suffer in pain. And that's why we need to split the work. Distributed task execution is the ability to split complex work across multiple machines or agents. The obvious approach would be binning, where we split the work into similarly weighted bins. So imagine if we have 10 projects and 5 agents, we would probably split them so that we run 2 tasks on each of the agents. But what if 4 of those tasks take super long while the remaining 6 are super smooth? Maybe it would be better to just run these 4 on separate agents and then combine the remaining 6 on a remaining agent. What if there's some different distribution of the complexity? And suddenly it's not that trivial. It's actually very hard to balance it well. There will always be an agent that was idle, while some others were overwhelmed. Binning also splits the result into chunks. So if I run the build, I want to see the results of all the builds in one place. I don't want to search through each agent, collect the results, and combine them together myself. So if one of the agents fail, I want my entire build to fail, not just that single agent. And on top of that, calculating the order to build in a fairly complex solution is a nightmare. A proper DT is very hard. It doesn't just split the commands, it splits only tasks, and it utilizes resources in an optimal way so that each agent is equally used. And it doesn't require any changes to CI setup apart from flagging it to run in distributed mode. Only Bazel and NX from the known monorepos have an implementation for it. Additionally, Bazel also supports remote execution, meaning you can trigger the command on your local machine, but it will run on a cloud. And once it's done, it will send the results back to your local machine, behaving as if everything was just run on your local machine. Code constraints are the next feature, which is personally a very dear feature to me. Imagine you worked on an experimental feature, and before you know it, one of your colleagues found it and made a reference to it in their own project. Now, not only do you have unplanned dependent on the code, but potential changes might turn out to be breaking changes for others. And if you realize at some point that, well, whatever you were building is a failure and you would rather remove the feature, bad luck, you can't. And now you end up maintaining the thing that you don't even use yourself. Setting the code constraints is a way of making sure your monorepo doesn't descend into chaos. By explicitly stating what type of project can depend on what other type of project, you can, for example, restrict situations where someone is trying to import React library into the Angular library, or a library would try to import an application and also create a circular dependency while at it. This is the only weapon against unmanageable architectures. This is the only weapon that makes sure your project doesn't explode. So all of this was somehow related to large enterprise applications. What if you have just one small project? Should you still be using monorepos? This one's easy. Absolutely yes. Each framework in your setup has its own way of running, building, deploying, and you need to know all those commands. I don't know about you, but switching frameworks always bugged me. Was it npm start, or is it npm serve, or was it npm develop now? Monorepos solved this by having unified commands to build, test, lint, deploy, or any other thing you prefer. And it's not just the command names. This includes also parameters being in sync. All you need to do is learn only one set of commands, and you're good to go, regardless of whether you're an Angular or React developer, you're building Next or Nest, Cypress, or ESLint. No longer you need to remember the exact commands, and you need to remember the changes between frameworks. Also, projects start usually with a simple CLI command generating a solution. Most of the time, this is unfortunately not enough. That's why there's so many boilerplate solutions out there. But what if you could make it more flexible? What if you could tell it what to generate? And not only at init point, but at any point during the lifetime of your application. What if you could tell it to generate the component shaped to your liking with a state management plugged in, with tests, lint, and end-to-end already set up for you? What if you could easily migrate from one version to another while the automation fixes your code for you? NX has all of that and more. It even provides a VS Code extension that gives you a nice UI with all executors and generators, so you can see what are the possibilities. And additionally, you can try out the commands as you type in the parameters and immediately see the results to your file system without it actually affecting the file system, so by running the dry run. Having this in a UI, it's also amazing because it bridges the gap for beginners. You don't have to know commands immediately. So let's recap what monorepo gives us. They bring clarity by providing workspace analysis and graph visualization. They also bring speed by leveraging the local and remote caching, task orchestration, detecting affected nodes, distributed task execution, and remote execution. And finally, monorepos make it easy for us because they provide code sharing, code collocation, powerful generators, consistent tooling, and code boundaries. If you'd like to know more about monorepos, you can head over to monorepo.tools, a page that was recently created by authors of popular monorepo solutions, where you can see all those features in a bit more detail. And there's also a nice and comprehensive comparison between different tools and their features. Otherwise, you can just take my word for it and use the NX. It will solve even the problems you didn't know you had. It's time to spend your time on things that matter, rather than waiting for the build to finish, and also save money for some nice gadgets or travel instead of paying it to the cloud providers. And in case you were wondering, using monorepos will not only make you a 10x developer, it will make you an NX developer. Thank you for watching and see you in the bright monorepo future.
Yay, can we leave some clap emoji in the chat for Miro, please? We have a few minutes for questions. So if you do have a question, post it in the chat and we can talk about it. While people think about what they want to ask you, I have a couple of questions for you, Miro, about the challenges of monorepos, which I am very much a monorepo fan. My job has one monorepo, which is the one I'm in, which is about 20 gigs, and we have to download it in chunks because it is too big. But it works and it's really great. How do you think working in a monorepo within like a company or an enterprise can either solve or enhance problems within teams, across organizations, etc.?
Yeah, so just to mention that I never worked on any monorepo that was large, like probably you have now in Twitter, or that Google or any of these big companies have. And I assume it's a monstrosity to download it the first time. But I think the monorepos generally improve the coordination between teams, because what usually happens is, even for smaller companies, is that there's a clean distinction between the backend people, the database people, the frontend people, and they don't really talk to each other. And also, if you have even on the same layer, but people just working on different products, they're not really in sync. And it happens often that someone implements a solution and the other team implements the same solution in a different way without communicating to each other. One thing that is especially amazing about monorepo is that it puts all those people together in one place, and it in a way forces them to talk and to change their mentality, because they're not anymore competing teams from the same company. They are one group of people working together on a joint cause. And this is amazing. This is something that we saw with all of our clients, that once they switch from monorepo, suddenly people that didn't talk to each other, or people that are like living on different parts of the world, start communicating together. And that's really amazing.
Awesome, thank you. Tanya asked, how do you think migrating a Yarn workspace with Docker builds Expo project to an X would be like in terms of complexity? Is it easy? A few days?
To be honest, not quite sure. We are working on an automated Expo plugin. I'm not sure currently what's the state, but it should be fairly usable at this point. So this might be just automatic step by just installing the NX with a NX Expo plugin, and it should handle everything for you. If not, there's always people either from Narval or people on a community Slack that would be ready to help. There's a lot of people using Expo with NX, so should be easy to find help.
We have another feature question. Michael asks, they use Lerna to manage public package releases to NPM with automatic version bumps across all the packages, publishing, etc. Does NX handle this use case?
Yes, absolutely. So our NX solution also is releasing our NX packages to the NPM, and it's doing automated version bumping. So this is pretty much what monorepo tools were built for.
It's its bread and butter.
Yeah.
Great. This one's a little fun. Have you tried New Kid on the Block Turbo Repo, and how does it compare?
So I only tried it when it was still in beta, and at that point, of course, it was quite buggy. So that's far from the current situation. I think it's very good for the entire monorepo world, because it brought the needed attention to the monorepos. And thanks to them, everyone is now talking about monorepos, and it also brought attention to our product, the NX. I think you can just head over to monorepo.tools, and there you can see in detailed comparison between not only those two, but also other competitors. And also there were some tweets from our co-owners, Victor and Jeff, that were doing a bit of performance comparison, performance benchmarking between these two. So I think there are some things that TurboRepo does better, but of course, at this point, we still have a huge advantage because NX is now quite old. It has been around for a couple of years, while TurboRepo is more or less just 1 year old. So there's still some catching to be done. But also, I think Jared mentioned that his idea is not to try to catch up with NX with features, but rather to focus on a subset and do this in a different way or better way. So there are quite some differences between these two. NX is supporting all the possible languages, not just JavaScript, while JavaScript is automated, but you can also use it with .NET, with Java, with Python, with Rust. While TurboRepo is at the moment, as far as I know, just focusing on JavaScript.
Interesting. I didn't know that it was for languages. Cool, thank you. Curious to see how that evolves. We have one person who says, I don't know how to create monorepos. Do you have any good resources they could go to?
Yes, if you go to annex.dev, you can see the guidelines how to create monorepos. And the similar thing you have for TurboRepo or for any other monorepo solutions. Usually it's just one command that you run and you convert your solution to monorepo.
Let me copy paste that in the chat.
Yeah, I can type it in as well.
Cool. Somebody asks, Turbo defines the interdependencies via the declarative pipeline keys. Lerna figures it out by itself. What would you say are the trade-offs? And of course, how does NX do it?
I'm not sure what the declarative pipeline keys means.
What I meant was that they have the pipeline tasks. They declare the pipeline on the JSON. So basically you can say which package depends on which other package, declarative. So it doesn't have any kind of heuristics to find that out. So you basically define the interdependencies between the packages, and that's how it creates the build or parallelize them. I just want to know if there are like any potential trade-offs that you see on the learn approach that basically figures it out by the dependencies, and how does NX do it? What you think is best?
So NX actually does both of the approaches. So you have explicit dependencies where we just, if it's JavaScript code, as I mentioned, NX supports JavaScript in automation. That means that if you have import from one project to another, it will read the import tag and it will know that these projects are linked. So that's explicit connection, the same way like Lerna just finds it out. Also, you can specify implicit dependencies. Like for example, if you have end-to-end project, it depends on your application, but there's no clear import from one to another. You just know that this end-to-end needs application to exist. So in this case, you have to specify it in your configuration. So similarly how TurboRepo does it, we also have project configurations where you can specify how these things are linked together. And I think, there's benefit of both. I think it's easy that you have less configurations. So if we can figure it out for you, it's always better than if you have to type in everything. Like for example, Bazel is an amazing tool, and feature-wise and complexity-wise, it can do a whole lot more than most of other tools. But every single thing you need to configure, and it just takes so much time and so much effort. So although it's an amazing tool, it requires someone to work on it full time, and that's usually not what people are ready to do.
Cool, thank you. I don't actually know what this is, but Renee asks, are Yarnberry projects supported?
Not at the moment. So I think that Yarn version 2 is pretty much abandoned project. There was a lot of backfire when it came out, and a lot of people were fighting against it. The version 3 now tries to sort it out and kind of get back on the track. We will probably at some point support it, but at the moment it's not on top of the priority list.